Yeah, in general, you're right. In general, so here, once I started to make these thermodynamic arguments, I was assuming the Cauchy stress the whole time, okay? And it is symmetric. But in general, the stress tensor is not symmetric. Now, so that's where these ideas like the first peel of Kirchhoff's stress is not symmetric. And in that case, you'd have to make these measurements in a frame. The elasticity tensor would be different depending upon, or is different depending upon which stress you're using. So from the rest of this class, we'll just assume it's the same. But beware, if you're dealing with very large deformations and you're using, say, the first peel of Kirchhoff's stress, then the material constants that you populate that tensor with will be different depending upon which stress you use. Okay? Now it turns out they're all related. You only have to measure them in one way, right? And then you can translate them to the other ones just through kinematic arguments, push forward, pull back operations. When I say push forward, pull back, I mean if you measure them in the laboratory or the reference frame, you can push them forward to the current configuration and use the constituent model there. Or if you measure them in the current configuration, you can pull them back to the reference frame and use the constituent model there. So these are topics that are really in a full continuum mechanics course where you talk about large deformations. But in a geomechanics setting, we don't encounter very large deformations or very large rotations. And so, we're sort of from here on out going to stick to small strains and Cauchy stress, because in that case, there's no difference. We make no distinction between reference and current configuration. Okay.